Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Binti Ramle. Today I would like to present about the introduction of gas absorption. Definition: gas absorption is mass transfer operation where one or more species is removed from a gaseous stream by dissolution in a liquid. The component that is extracted from a gaseous stream is known as a solute, and the component that is extracting the solute is known as a solvent. Advantage of gas absorption: first, low pressure drop required. Second, small diameter possible. Third, low capital operating and maintenance cost. Four, can handle corrosive material. Five, simple construction. Disadvantage of gas absorption: first, fewer stage compared to other column. Second, channeling, which must be controlled by retributing liquid. Third, cannot handle extremely high or low flow rate. Four, cannot handle liquid with high viscosity. And five, need to be professionally wetted to avoid reduction of interfacial area to volume ratio.
Hi, my name is Farhana Zakiah. I would like to explain about the gas absorption mechanism and the packing. The fundamental physical principles underlying the process of gas absorption are the solubility of the absorbed gas, or also we call as solute, and the rate of mass transfer. Pack tower is the most commonly equipment used in the gas absorption process. The mechanism of gas absorption in pack tower is the feed gas and the liquid solvents flow countercurrently, in which the gas mixture is introduced at the bottom of the column and the liquid solvent is introduced at the top of the column. As you can see, the picture here illustrates the process of gas absorption inside the pack column tower. The inlet gas, which is being fed at the bottom of the column, rises upward through the openings and contacts with the descending liquid, which is flowing through the same openings. The outlet product will be the desired gas at the top of the column and the liquid outlet at the bottom. The gas flow is driven by the pressure, while the liquid flow is driven by the gravity force. There are a few principal requirements of a packing. It should provide a large surface area, have an open structure so that the gas flow has a low resistance, promote a uniform liquid distribution on the packing surface. And the last one is promote a uniform vapor gas flow across the column cross-section. Packings can be divided into two classes. The first one is random packing, such as ring, saddles, and proprietary shapes. And the second one is structure packing, such as stake rings, grids, and proprietary structured packing, is shown in these figures here.
Pack tower performance. The performance of the pack tower is dependent on one physical factor, which is the flood capacity, because its state will affect any other parameters. Flooding is a process in which gas flows in one direction and follows liquid flowing in the opposite direction in the pack column. Flooding is undesirable because it can cause large drop in pressure across the pack column, as well as the other undesirable effect on the performance and stability of absorption process. For this reason, in design of absorption column pack, several parameters need to be addressed in order to achieve good performance and prevent flooding problems. At the point called loading point, the downstream liquid is slowed down by the gas and can no longer flow through the packing. The operation will therefore be disrupted as the liquid blows out of the gas. The higher the gas flow rate, the greater the liquid. The first calculation has been developed since 1935 by Sherwood et al. Using an air-water system data to represent flood capacity with a series of exist parameters. A correlation was developed to increase the accuracy of predicting a drop in pressure, and the latest version was introduced by Stringle. Packaging factor is calculated experimentally for all forms of packaging. In a pack tower structure, it is important to determine the drop in the flooding pressure in order to avoid the over-restriction of the gas flow rate, which is negatively affect the efficiency of unit process. The prediction of flooding pressure drops can be determined by using an equation which has been developed by Kister and Gill. The equation can be reduced as below.
My name is Syamimi and I will present types of tray tower. There are three types of tray tower, which are sieve tray, valve tray, and bubble cap tray. In sieve tray, vapor bubbles up through simple holes in the tray through the flowing liquid. Hole size range from 3 to 12 mm in diameter with 5 mm a common size. The liquid is maintained on the tray surface and prevented from flowing down through the holes by the kinetic energy of the gas or vapor. The depth of the liquid on the tray is maintained by an overflow outlet where the overflow liquid flow into the downspout to the next tray below. Next, modification of sieve tray is valve tray, which consists of opening in the tray and leaf valve cover for each opening, providing a variable open area which is varied by the vapor flow inhibiting leakage of liquid down the opening of low vapor rates. Hence, this type of tray can operate at greater range of flow rates than the sieve tray, which costs only about 20% higher than a sieve tray. Lastly, bubble cap is generally superseded by sieve tray because of their cost, which is almost double than sieve tray. In the bubble tray, the vapor or gas rises through the opening the tray into the bubble caps. Then the gas flow through slot in the periphery of each caps and bubble outward through the flowing liquid.
Hi, I'm Tariq, Ishraf, and Lukman, and I will be presenting the daily application of gas absorption. For the first example that we'll be looking at is that minerals carried away by rivers. Now, rivers are the transport material in four ways, which are solution, saltation, fraction, and suspension. Because we're only interested in gas absorption, we will only look into solution, which is minerals are dissolved in the water and carried along in solution. This typically occurs in areas where the underlying bedrock is limestone or chalk. For the second example, we'll be looking into carbonated beverages. Have you ever noticed these drinks? And did you know that these drinks also are made by gas absorption too? Now for the third example, water aerators. Along lakes, have you ever noticed these aerators? The aerators function to propel the water into the air, and it breaks the water into small droplets. Now these small droplets have large surface of area, through which oxygen can be transferred. Upon return, these droplets mix with the rest of the water and thus transfers that oxygen back into the ecosystem. So there, it also applies gas absorption. Thus, those are the three daily applications of gas absorption. Thank you.
My name is Mohamad from Zamir Sazali, and I will present about the application of gas absorption. Primarily, the process of gas absorption is used in the regulation of air pollution. It is applied in the removal of harmful or unwanted components in the gas stream. The role of gas absorption in the industrial air pollution control is becoming increasingly important, but as the time goes by, the use goes beyond the air pollution control. It has become the most important method of separation in many chemical industry. Some of its applications include during the manufacture of ammonia, the oil desulfurization, the manufacture of hydrogen, and the manufacture of ethylene. The process helps the removal of the unwanted gases to give only the required component. For example, in case of hydrogen manufacturing, the air that comes into contact with the scrubbing liquid is dissolved and give only a hydrogen solid.
Hello, I'm Nurul Nabia, Binti Fauzi. Okay, overall, we can conclude that absorption is still one of the most important separation process in chemical and petrochemical industry. Although absorption has reached a high level in theoretical understanding, process design and technical implementation, nowadays industrial work on this unit operation is full of economical techniques and scientific challenges. As for the economical aspect, the economical interests concerning absorption are quite different regarding the various space in the markets. For chemical and process industry, absorption has to be the most cost-effective separation technology compared with another alternative pathway and compared to the other technologies competitors. Okay, for the future aspect, several new applications of absorption will occur with increasing importance of gas based on the techniques and environmental demands. As example, the CO2 capture from conventional power plants. Since these power plants contribute to the global anthropogenic CO2 emission to be a very large extent, then the associated flue gas from these plants are large and the heat requirement for regeneration of today's available solvents are very high. Then this problem can be considered as one of the most challenging tasks in chemical engineering in this century. Due to the low available partial pressure, CO2, chemical absorption has to be favored for this task. Regarding to its complexity today, the industrial absorption is well developed and established unit operation, as commercial absorption is often the cash flow and not only for off-gas treatment. News and exciting challenges, especially concerning new application, occurs for absorption. Several lacks in these existing models and databases have to be clarified, since all works can also be done by a fundamental understanding of this unit operation. Also, a problem-to-problem based strategy fails of extensive physical, chemical, and mass transfer phenomena and also parameter involved in this absorption. That's all from our group. Thank you for your time and hearing our presentation.